morning. So today we will be spending time in developing 6 DOF or 6 degrees of freedom, 6 degrees of freedom equations of motion. Equation of motion. And by now you know what are the 6 degrees of freedom. If this is the airplane, we have x, y, z. So one motion, translatory motion along x, along y, along z, and rotation motion about x, y, z. That is x, y, z, these 3 motion, and this, and this. Right? There are 6 degrees of freedom. What is the meaning of that? Meaning thereby, what is our interest? Our interest when we develop a 6 DOF equations of motion, we say the airplane is moving. I want to give a disturbance to the airplane and see how it is responding in terms of all these 6 degrees of freedom. And from that response, we would like to utilize it conveniently to understand whether the aircraft is dynamically stable or not. Our aim is for dynamic stability analysis. Let's not forget that. That is our basically aim. Why we are developing this 6 DOF equation of motion? Our primary aim is to study dynamic stability of airplane. 6 DOF equation of motion can be used for so many things. If you want to know up to what range it is going, how it is moving in different directions, you also can do that. But we are very clear about this. This equations of motion we are developing with clear understanding in our mind. We will be studying the dynamic stability of an aircraft. We have already completed static stability of an aircraft, right? And now, how to develop the equations of motion? You know, this F is equal to ma, and applied moment is d by dt, rate of change of angular momentum. Okay? But the constraint is, when you want to apply this, you have to be very, very clear that this should be applied with reference to inertial frame. That is important. And what is the inertial frame? A frame which doesn't have any acceleration. And for our purpose, we have assumed earth fixed axis system, which is, we are calling that is our inertial frame, because we are neglecting the rotation of earth. Okay? So for an aircraft, this is a good enough assumption. Let me tell that this xe, ye, ze be the axis system for earth fixed, which is for us is inertial frame of reference. Right. So what I can do is this equation, if I go in between, I can write this is nothing but d by dt of m into v, and this is equal to m dv by dt plus v dm by dt, right? And we are assuming that dm by dt is 0, the mass is constant. Why this is okay for us? We are doing a stability analysis. Our aim is to do dynamic stability analysis. So we will be studying the response of an airplane for a short duration, right? For example, it is in the cruise. Now we give some deflection and see what is happening. But this study will be for a very short duration with respect to the trim condition. And during that short duration, it is fair enough to assume that the fuel consumption is very negligible. So this assumption is okay. So why this assumption is okay? Because we are doing it for stability analysis. Stability analysis and time duration of study. Time duration is very small. So it is fair enough to assume that fuel consumption is 0 or negligible, right? So the weight remains same. So dm by dt is 0, fine. So I write F, which all of us know is F external, is m dv by dt correct? Now, let us go a little bit deep into this expression. Remember, we are developing this equation number 1 with refer to inertial frame of reference, which is earth axis. So, now I can write V as U earth into I of earth, or let me write U for clarity, U I earth plus V J earth plus W K earth. What is the meaning of this? This is, I am resolving V, total velocity, along I J K of inertial frame of reference, correct? Okay. So, if I further try to understand, suppose this is your IE vector, this is your JE for your inertial, and this is ZE, and suppose this is the velocity vector V, then I am taking the component of V along IE, and that is U, component of this V vector along JE is V, and similarly component of V vector along ZE is W. So, if I put F is equal to M dV by dt, so it will be d by dt of V. For V I write U IE plus V JE plus W KE, like this. This is a total velocity V. Notation wise, don't get confused. This is the component of V along inertial frame y axis, right? So, now if I take derivative, I get M du by dt into IE plus M dV by dt into J earth direction plus M dW by dt in K earth direction. Please see here, when I was taking the first term derivative, ideally it should be M du by dt. So, let me write du correctly, du by dt I plus U di by dt, right? Here, if I expand this, this should be M du by dt I plus M U dIE by dt. But I know it is an inertial frame of reference, so IE, JE, KE are fixed. So, they are not changing the direction. So, this is 0. So, I have not put those terms here. So, from here now you can easily see F vector is having Fxi E plus Fy J plus Fz K. And what is Fx? Fx is nothing but M du by dt. What is Fy? It is M dV by dt. What is Fz? M dW by dt. Okay. There is no problem on that. Similarly, if I do this M summation of Fd by dt to h, and I write h as angular momentum as hx, x component along earth inertial frame, and hy into je plus hz into ke. So, these are component of total angular momentum along inertial frame, which is earth fixed IE, JE and KE. So, if I put this thing here, I can write M as LIE plus M JE plus N KE. So, what is L? L is the nothing but Hx. So, L equal to d by dt of Hx. This is clear? M is d by dt of h. So, d by dt of this vector. So, if you are not clear, let me repeat here. So, d by dt of h, it means this is equal to d by dt of Hx IE plus Hy JE plus hz ke. So if I expand it, I get value dHx by dt IE plus dHy dt by JE plus dHz by dt into KE. No problem? Clear about it? So for this, I am writing as L. For this, L, for this M, and for this N. So I can write this as LIE plus MJE plus NKE. See, whenever I am deriving some expression, please understand, since I don't have any interaction, wherever I get inside that, I am a bit fast, and you may miss the point, I go on repeating it. In fact, you will find many lectures I repeat on the next day. So that is what that sort of a thought comes to me when I review it, when I see, when I think what I have done today. So please use your open forum very aggressively. Wherever you are not able to understand, just write me, drop me a line. Okay, fine. Now let us come back to the physics. What is L? What is L? L, if you see here, is d by dt of Hx. What is Hx? So let us ask a question, what was H? H vector was the total angular momentum. And total angular momentum about which axis? Obviously, we are all working in inertial frame. So it is about inertial frame IE, JE, KE axis. Correct? So what is dHx by dt? This is the component along x direction. Right? So component along x direction. Please try to develop understand the physics so that you are not lost in this term. And very simple. Component along x axis, this is y and this is z, ze, xc, since you are working with earth fixed inertial frame. So this is the moment, rate of change of angular moment. Who causes this change in angular moment? That means some external applied moment must be there. Like who causes the rate of change of momentum? In linear case, it is external impressed force. So who will cause the change in the angular momentum? That is some external impressed moment. So this is nothing but about x axis. So it is rolling moment. L is about x, rolling moment, right? So this part is rolling moment. So this is about x axis. Clear? I repeat, like you have F equal to m or d by dt of mv. So what is our understanding? That this external force which causes the rate of change of linear momentum, right? So now if I write m is equal to dH by dt, what is my interpretation? This external moment causes change in the angular momentum vector. This is the external moment applied on the body. And this angular momentum being vector has three components along IE, JE and KE axis. And this rate means the rate of change of angular momentum along IE, similarly along JE, along KE. And this part is about x axis. So this is like a rolling, right? This moment will cause rolling. Okay? So this is called rolling moment. L is rolling moment. What about m? M is similarly you see d by dt of hy. So about y axis. So if this is the plane, this is the x and this is the y. So about y axis, which moment will be there? This is pitching moment, right? So this is pitching moment. And then if you see n, here n equal to d h z by dt. So this n will cause this dH by dt, dHy by dt, the other components, right? Scalar components, and direction is given by ijk. So I have removed this vector sign here, right? So ideally I should write m, which is basically about y axis, right? Pitching moment. Similarly, n, if I come here, Sz, about rotation about z axis. So this is nothing but yawing moment. Okay. And by now you are smarter, you know rolling moment positive is when right wing going down, yawing moment positive is when right wing going back, and pitching moment positive is when nose goes up. All these things we have clearly understood. So this is the component, and let us see what is the next step. Let us not forget that we are writing this equation of equations of motion which refer to inertial frame, which is for this particular case is earth fixed frame. Okay. So now let us do one thing. We draw an airplane. I always say whenever writing expression, do not forget you are working for an airplane, so that insight should not be missed. The airplane is the center of gravity, and I am taking any mass delta m. Okay, and as you know, now we are drawing body fixed axis system. So I will use the word xb, then this is yb, and somewhere here this will be zb. B means body fixed axis system. What is the beauty of this body fixed axis system? That it rotates with the body. It is body fixed and located at the center of gravity here. X axis I can align depending upon our requirement. Sometimes we align x axis in such a way that it becomes a plane of symmetry. Okay? The vertical plane becomes plane of symmetry. Advantage is if I put x axis like that, you will see we can put the value of some cross moment of inertia equal to 0. So that simplifies our case. Assume that xb is along the fuselage reference line. We are not putting any condition on xb. We will put it as and when required, right? And let's denote this as r bar. R bar is the position vector of this mass delta m with respect to cg. Okay. So let me clearly write this. What is delta m? Delta m is the mass element under consideration. That is total mass, you are distributing into small particle, right? And remember, we have assumed that this airplane is rigid. So the relative position between 2 points physically remains same, they don't change, right? So delta m is the mass element under consideration, and V is the, let's say I have to give V somewhere here, let's say V. What is V? V is the velocity of the mass element with respect to inertial frame. V is the velocity of the mass element with respect to inertial frame. Notice that I have drawn this V as the velocity of the center of gravity. Am I correct? What did I write here? Velocity of the mass element with respect to inertial frame. So this is not correct representation. This represents what? This represents velocity of the center of mass. Please understand, this represents the velocity of the center of mass. But what V I am talking about? Velocity of the mass element with respect to inertia, this velocity of this element. And you can understand the velocity of this element and this element need not be same, because if a body is rotating like this, say rotating about Cg, then even if the Cg is not moving, but these points are having a velocity omega cross r, right? So this point velocity and this point below center of mass are not same in general. So this is, understand, this is V, velocity of the mass element, and this is Vc, velocity of the center of mass. This should be very, very clear. Okay. Once I am very clear about it, then I write delta F. Delta F is the resulting force acting on dm. So, what could be these resulting forces? Aerodynamic forces, gravitational forces, right? For airplane, these are two forces, and propulsive forces will act in general through the propulsion mechanism, either it is a propeller or it is a jet engine, right? So, this is the total resulting force acting on dm. So, now I can use, because I am working in inertial frame, everything I am now developing in inertial frame. Delta F I can write as delta m dv by dt. Please note that this is dv by dt, not dvc by dt, because I am writing what is the effect on the mass delta m because of external force delta F acting on dm. This delta F is acting on dm. So, I draw a line like this so that you clearly understand. This is the external force acting on dm, which is causing acceleration dv by dt, or which is changing the momentum, right, in accordance with Newton's laws of motion. And definitely we are particular, we know how to apply Newton's laws of motion. So, we are applying all these things in inertial frame, which is earth fixed. So, every measurement is made with respect to earth fixed, right. That is, if I am talking about this velocity v, this is measured with respect to earth fixed axis system, okay, which is fixed and inertial frame. That should be very, very much clear to you. Now, I can write, let me write this, one is summation of delta F is F, that is total force F, vectorially added, and we know that V equal to V center of mass plus dr by dt. No problem. The velocity of this particle v, because that is important for us here. Please note that we want to relate this velocity v, which is velocity of the mass element, with center of mass speed or velocity. Okay. So, this velocity at this will be velocity of center of mass plus dr by dt, because if it is moving like this, it could move like this. So, that dr by dt will come here. So, this is the expression. Then I can write, of course, Vc is velocity of center of mass with respect to this. I will be inertial frame. I will keep on writing so that it goes into your mind, and dr by dt is velocity of elemental mass, velocity of dm with respect to what? Dr by dt, r is measured. What is r? Let us understand. R is the position vector, that is, it tells you where this delta m is located with respect to what? Is it with respect to inertial frame? No, it is with respect to center of mass, right? This r is respect to center of mass, which I am writing as Cg. So, for general situation I write center of mass. Clear? So, what is dr by dt? This is the velocity of delta m with respect to, since r was with respect to center of mass. So, dr by dt is also with respect to center of mass. For us it is center of gravity also, similar concept is same, right. So, this is clear. Then next we go for a little bit of more involved equations, very simple equations, but more important, please understand, you should understand the physical meaning of it, and once you understand that, then these things are on your fingertips. Don't memorize anything here. Any problem, anywhere you are not able to understand, use the forum aggressively. Okay. So, let us see what is F. F external was summation of delta F, and by Newton's law, we know delta F equal to m dv by dt. So, for a delta m mass element, it is delta m dv by dt. And what was v? V we have just now represented as velocity of center of mass plus dr by dt. This was with respect to center of mass, and this is with respect to the inertial frame. So, I have substituted this here to get summation of delta F equal to total F is d by dt of summation of Vc. For V, it is Vc plus dr by dt, like this, and delta M is here. This is the total force F. This was force on single element. Summation means total force. So after this, what happens? If I expand, then I get F equal to m dVc by dt plus d by dt of summation dr bar by dt into delta m. So again, I do little manipulation. I write F equal to m dVc by dt plus d square by dt square summation r bar dm or delta m. Right? This is clear? M dVc by dt, m dVc by dt, then d summation, so this has been taken out, so d square by dt square summation r dm. What is summation r dm? What is summation r dm? Please note that we have ensured that the axis system is at CG location, right? So if this is the airplane, then axis system is at center of mass. So by this definition, this automatically becomes 0. Why? Because how do we define center of mass? Any center of mass location is summation of RDM by summation of DM. Now since your axis, let's say axis is at CG, so this value becomes 0. So naturally RDM becomes 0. This is definition of center of mass. Okay. So I am sure you should be able to understand this. If this is 0, then what I am having is F is equal to m dVc by dt. What is the physical meaning of this? Try to understand that. Okay. F equal to m dVc by dt. Vc is the velocity of center of mass with respect to inertial frame. What is the meaning of this? We started doing, this is the body, we took element mass, and you say this is delta F acting, another mass delta F2, another mass delta F3. So let's say all these forces are acting in general direction on this body. Okay. Now how to apply Newton's law? This tells you the way to handle it, as long as we are working in inertial frame of reference. Or says, forget about the delta mass and all this thing. Find out what is the center of mass of whole of this delta element. So this is center of mass, or for our case it is CG also, right? Okay. Once you have located that point, then assume that whole mass is at that center of mass. And this is applied by a force F, which is resultant of this force. So now you apply this. So this will tell you, if there is the external force m, what will be the acceleration, overall effect on the acceleration of the center of mass, right? And that is what we are looking for, because we also want to track how the center of mass of the airplane is moving in flight, right? Okay. So this is a very useful equation we will be using. 1. So this talks about center of mass moving, what is the velocity vector, but we also like to know what are the angular velocities, isn't it? Because it has got not only 3 degrees of freedom, it's 6 degrees of freedom, UVW, PQR, that is angular motions. So this equation is good as far as velocity is concerned, but now we have to look for the angular motion. Okay. And who causes the angular motion? Like F causes linear motion, and angular motion is caused by the moment, right, which is also an effect of force, right, moment. So we will use the moment equation. What was the moment equation? Again, delta m equal to d by dt of delta h. So, recall what is delta h? Delta h is the angular momentum, elemental angular momentum, and which is caused by moment acting on that element m, right. So, this I can write as, by definition, d by dt. Definition of angular momentum is, it is moment of the momentum, remember, moment, angular momentum. If I want to define angular momentum, go back to class 11, 12, angular momentum, it is actually moment of the momentum, and it is defined as r cross mv, right? Okay. So, now what I will do, I will write here r cross v delta m, right? It's r cross mv written in this fashion, right? This is rate of change of angular momentum, and what is v? V we have seen, Vc center of mass plus dr by dt, and dr by dt was with respect to center of mass, but Vc was with respect to the inertial frame, and this I can write as Vc plus omega cross r, where omega vector is the angular velocity with respect to what? With respect to inertial frame, right? Don't forget that. This is with respect to inertial frame. And r, you know, r is position vector measured with respect to center of mass, right? So, omega will have again three component, one p along IE axis, q along JE axis, plus r along KE direction, unit vector direction. IE, JE, KE are the unit vectors of the inertial frame, which is for us earth fixed frame, because we have neglected acceleration of the earth. Okay. So, now we are trying to define the expressions of our h, the angular momentum, and just to recall, remember angular momentum we interpret in class 10th, 11th, 12th as it is the moment of the momentum, moment of the linear momentum, right? Okay. So, I thought it should help you to understand. So, moment is r cross force. So, moment of a momentum is r cross mv. So, here r cross mv, m delta m I have taken out, v is here. So, this if I write, remember v is nothing but v equal to Vc plus omega cross r. Now, we will try to develop equation so that we can find out the angular motion, right. For that, you know, we need angular momentum, like for linear motion, for modeling equations to derive or to predict or to compute linear motion like u, v and w, we use linear momentum. For angular motion, we will be using angular momentum. And what is angular momentum? If you recall, it is in, if you go back to class 10th, 11th and all, it has to be defined as moment of the linear momentum, right. So, we are using that concept, h angular momentum is moment of the linear momentum. So, v bar delta m is the linear momentum of an elemental mass, moment is r cross that, and that is on summation means it is the total vector sum. And v, you know, v is Vc plus omega cross r. So, that is substituted here, v equal to Vc plus omega cross r. So, I have the h expression as summation r cross Vc plus omega cross r delta m here. So, again if I modify it, it will be summation r delta m and Vc first term plus r cross omega cross r delta m. And by now, you know, if axis is at the center of mass or center of gravity, this gentleman is 0. So, we have an expression of h as summation r bar cross omega cross r dm, right. Here, let us not forget this term vanished because the axis is located at the center of mass. Okay. So, this is very clean now. You see, I have to use this relationship because H has got component like Hx IE plus Hy Je plus Sz Ke, which are the unit vectors. So, omega I will expand as P IE. Let me write this, then I will explain Q Je plus R Ke. What is the meaning of this expression? This is the angular velocity which has a component P along Earth's fixed x-axis, Q along Earth's fixed y-axis, component R along Earth's fixed z-axis. Similarly, I can write R as x IE plus y Je plus z Ke bar. What I will do now? I need to find Hx, Hy, Hz. So, I will operate this. I will put R here. I will put omega here, and I will use the property of vector triple product, and I leave it to you. You should be able to derive it. And if I do the vector triple product expansion, I will get expression like this. I will get. Let me write the expression. I will write Hx equal to P Ix minus Q Ixy minus R Ixz, then Hy as minus P Ixy plus Q Iy minus R Iyz, and Sz equal to minus P Ixz minus Q Iyz plus R Iz. And you know that what is Ix? Ix is the moment of inertia about x-axis. Ixy, Ix are cross moment of inertia, and you should be able to easily derive this by using these two information. Okay, I leave it to you at this stage, and if you do not feel comfortable to come from here to here, which I am sure should not be the case, right? You are all engineering student now. These things you have done many a times. I am writing all these things to familiarize you so that you can go to the aircraft equation of motion. And if you cannot do that, anyway, we will be putting after getting your feedback, and we will post it for yourself, getting understanding of it, right?